Hey champion, welcome to your EduBuddy the Scholar. As classes have already been started in your respective institutions, hope you are all rocking. And as always, the content of the Scholar will certainly help you to take you to the next level and hence helps you to crack the NEET and IIT numericals in the best possible manner. Today's concept is the force of attraction between any two bodies in this universe is called gravitation. Moving into the history of gravitation, Claudius Ptolemy proposed geocentric theory according to which all planets including sun are revolving around the earth. This was proposed way back in 2nd century. Later in 14th century, Copernicus proposed heliocentric theory. According to this theory, all planets including earth are revolving around the sun. As we know, whenever a body is in motion, it should follow certain rules during its motion. Simultaneously, these astronomical bodies also follow certain laws of motion which were proposed by Kepler, hence are called as Kepler's laws of planetary motion. There are three Kepler's laws. Let us learn one by one. The first law of Kepler. According to this, every planet revolves around the sun in an elliptical orbit with the sun lying at one focus of the ellipse. This is also called law of orbits. The second law, the aerial velocity of a planet around the sun is constant, or every planet sweeps out equal areas in equal intervals of time. Hence, Kepler's second law can also be termed as law of areas. Kepler's second law can be mathematically represented as dA by dt is equal to constant, where dA is the area swept around by the planet in a time dt. The aerial velocity dA by dt is equal to half r square. Since dA by dt can be termed as omega, we can write omega is equal to half r v. Otherwise, dA by dt is equal to half m r square omega by m, which becomes I omega by 2m, otherwise L by 2m, where L represents angular momentum. From the above equation we can infer that I omega, that is the angular momentum, is constant. Therefore, Kepler's second law is a direct consequence of the law of conservation of angular momentum. According to Kepler's second law, when a planet is close to the sun, its speed is maximum, and when it is far away from the sun, its speed is minimum. Hence, we can write angular momentum L is equal to mvr is constant, otherwise Vr is constant. Thus, V1 R1 is equal to V2 R2. Here, V1 and V2 are the velocities of the planet, whereas R1 and R2 are the distances from the sun respectively. Moving on to the third Kepler's law, it is also called law of periods. According to Kepler's third law, the square of the period of revolution of a planet around the sun is directly proportional to the cube of the semi-major axis of the elliptical orbit. This can be mathematically represented as t square proportional to r cube, otherwise t square by r cube is constant, or t1 square by t2 square is equal to r1 cube by r2 cube. According to Kepler's third law, as the distance of the planet from the sun increases, the duration of the planet increases. Newton's universal law of gravitation. Newton's universal law of gravitation. According to Newton's universal law of gravitation, every particle in the universe attracts every other particle with a force, and this is directly proportional to the product of their masses, that is m1 into m2, f proportional to m1 into m2, inversely proportional to the square of the distance between them, f proportional to 1 by r square. Let this be equation 2. From the equations 1 and 2 we get f proportional to m1 m2 by r square, f is equal to g m1 m2 by r square, where g is gravitational constant. Its value is 6.67 into 10 power minus 11 Newton meter square per kg square. Let us understand the relation between small g and capital G. Here, small g represents acceleration due to gravity and capital G represents gravitational constant. Before going into the relation between small g and capital G, let us learn the definitions of the same. First, acceleration due to gravity. The unit acceleration developed in a freely falling body due to Earth's attraction is called acceleration due to gravity. It is denoted by small g and its value is 9.8 meter per second square. The next one, gravitational constant. The force of attraction between two unit masses separated by an unit distance is called gravitational constant. Here in the picture you can observe we had considered two unit masses which are separated by unit distance. Then from Newton's universal gravitational law, the force of attraction between them is given by F is equal to G m1 m2 by r square. Here both the masses are 1 and the distance between them is also 1. Now it becomes F is equal to G into 1 by 1 square. From this we can write F is equal to G. Thus the force of attraction between two unit masses separated by a unit distance is called gravitational constant. The relation between small g and capital G is obtained from Newton's universal gravitational law. From Newton's universal gravitational law, F is equal to G m by r square. Here F represents force. Force can be taken as ma. Since acceleration a is nothing but acceleration due to gravity, here we can write mg in the place of F. Thus it becomes mg is equal to capital G m by r square. M and m get cancelled. The remaining g is equal to gm by r square. This can also be written as gr is equal to gm by r. This is to derive an expression for the variation of acceleration due to gravity above the Earth's surface. That is, the variation of acceleration due to gravity with height. When an object is on the surface of the Earth, it is said to be at a distance equal to the radius of the Earth. Thus, acceleration due to gravity, small g, is given by gm by r square. Equation 1, where capital G refers to universal gravitational constant, m refers to the mass of the Earth. When the object is at a height h above the Earth's surface, then the distance r can be taken as r plus h, where capital R represents radius of the Earth and h is the height at which the body is placed above the Earth's surface. Now, the acceleration due to gravity at this height h, which is referred to as gh, can be given by gm by r plus h whole square, taken as equation 2. Dividing 2 by 1, we get gh by g is equal to gm by r plus h whole square into r square by gm. Here gm and gm get cancelled. The remaining can be written like this: gh is equal to r square by r square into 1 plus h by r whole square into g. Cancelling r square, we get gh is equal to 1 plus h by r whole power minus 2 into g. If h is very smaller than the radius of the earth r, then gh is equal to g into 1 minus 2h by r. From this we can infer that as the height increases, the value of acceleration due to gravity small g decreases. This is to derive an expression for the variation of acceleration due to gravity above the Earth's surface. This is to derive an expression for the variation of acceleration due to gravity with depth. Let us learn as how the acceleration due to gravity changes with the depth. Let us assume that the Earth to be homogeneous uniform sphere of radius r, mass m, and of uniform density ρ. We know that acceleration due to gravity small g is equal to gm by r square. Also, from the definition of density d is equal to m by v, we can write mass m is equal to volume into density. Since Earth is considered to be a homogeneous uniform sphere, the volume of Earth can be taken as 4 by 3 pi r cube, where r is the radius of the Earth and rho the density of the Earth. Thus, mass m becomes 4 by 3 pi r cube into rho. When we substitute m with 4 by 3 pi r cube rho, we get g is equal to 4 by 3 pi rho g r. Let this be equation 1. Now, consider a body of mass small m be placed at a depth d. The acceleration due to gravity at a depth d is given by gd is equal to 4 by 3 pi rho into r minus d into capital G. Let this be equation 2. Dividing equation 2 with 1, we get gd by g is equal to 4 by 3 pi rho into r minus d into g by 4 by 3 pi rho g r. We can cancel the similar terms like 4 by 3 pi rho and g in the numerator and denominator. The leftover is gd by g is equal to r minus d by r. This can also be written as gd is equal to g into r minus d by r. Taking LCM, this equation can be written as gd is equal to g into 1 minus d by r. From this, we can infer that the value of acceleration due to gravity decreases with depth. Let us have a vivid information on gravitational potential energy. By definition, gravitational potential energy of a body at a point in a gravitational field of another body is defined as the amount of work done in bringing the given body from infinity to that point without acceleration. Moving on to the derivation part for gravitational potential energy. Consider a gravitational field due to Earth of mass capital M, radius capital R. The mass of the Earth can be supposed to be concentrated at its center O. Let us calculate the gravitational potential energy of the body of mass small m placed at a point P in the gravitational field. Here OP is equal to r and r is greater than the radius of the Earth. Let OA is equal to x and AB is equal to dx. The gravitational force on the body at A is given from Newton's universal gravitational law as F is equal to gmm by x square. Let this be equation 1. A small amount of work is to be done in bringing the body without acceleration through a small distance dx is given by dw is equal to force into displacement, which is taken as dw is equal to f into dx, or dw is equal to gmm by x square into dx. Here we have substituted the value of f from equation 1. The total work in bringing the body from infinity to that point P is given by w is equal to integral tends to infinity to r gmm by x square into dx. As capital G, M and M remain constant, these need not be integrated. Hence, the above equation is written as W is equal to gmm integral tends to infinity to r x power minus 2 dx. This is equal to minus gmm into 1 by x tends to infinity to r. This is equal to minus gmm into 1 by r minus 1 by infinity. As we know, 1 by infinity is equal to 0. When you exclude that, W work done W is equal to minus gmm by r. The work done is stored in the body as its gravitational potential energy. The work done we have calculated above can be treated as gravitational potential energy U. So, U is equal to minus gmm by r. Gravitational potential energy associated with particles of masses m1 and m2 separated by a distance r is given by U is equal to minus gm1 m2 by r. If U is equal to 0,
we all know that whenever a body is thrown up, it comes back to the ground again. But if bodies are thrown with a velocity 11.2 km per second, then they escape from the Earth's attraction and enter into space. Rockets are projected with this velocity, rather a bit greater than this velocity, to escape from Earth's attraction and enter into space.
escape velocity, the minimum velocity required for an object to escape from the gravitational influence of the earth is known as escape velocity, and it is denoted by VE. Now let us learn the expression for this. Let the mass of the earth is m and radius is r. Consider a body of mass m is on the surface of earth. The force of attraction between earth and the body is given by F is equal to G capital M small m by r square. To impart escape velocity in the body, some work must be done against the force of attraction. This work imparts kinetic energy with which the body escapes from Earth's attraction and moves to a distance r. Kinetic energy is equal to the work done on the body. Half mve square is equal to G capital M small m by r square into r. mv square by 2 is equal to G mm by r. V square by 2 is equal to Gm by r. V square is equal to 2 Gm by r. Ve is equal to root Gm by r. From the relation between small g and capital G, Gr is equal to Gm by r. Thus, Ve is equal to root 2 Gm by r. Ve is equal to root Gr. This is the equation for escape velocity. The escape velocity on the earth Ve is 11.2 km per second.
velocity with which satellites revolve around a planet is called orbital velocity.
The minimum velocity required to put the satellite into its orbit around the Earth is called orbital velocity, and it is denoted by V0. Let us derive an expression for this. Consider a satellite of mass m is at a height h from the surface of Earth of mass M and radius r. According to Newton's universal gravitational law, the force of attraction between the Earth and satellite is F is equal to g by r plus h whole square. Let this be equation 1. The centripetal force developed due to rotation of Earth is F is equal to mvo square by r plus h. Let this be equation 2. From the equations 1 and 2, we get g by r plus h whole square is equal to mvo square by r plus h. If h is negligible compared to the radius of the Earth, we can write the same equation as vo square by r is equal to gm by r square.
This was vivid information on the concept. Hope you have followed. If you have any sort of difficulty in understanding the concept, just freeze the video at the place where you did not follow. Go through the content again and again till you get it. Don't hesitate. If you still feel it difficulty to understand, please don't hesitate at all either to call me on the number 630982436 or mail me at kvrphysics369@gmail.com. Once I receive the message on WhatsApp on this number or in the email, I'll respond personally to your query and help you out in solving your problem. Thank you for watching. See you again in the next video. Bye-bye.